In this video, we're going to look at an example of a velocity graph, and we're going to analyze this velocity graph. So let's say we're going for a jog, and you travel in a straight line with a velocity function v of t equals 5 minus t, which is this graph right here, where time is in seconds. So first, let's talk about different parts of this graph, what they mean, how we can interpret this graph. So I have some text here. So when the velocity is positive, it means we're moving forward along the line. And when the velocity is negative, it means we're moving backwards. Which means, at this point, time equals 5 seconds. We hit the x-axis, which means we're switching from moving in the positive direction, forward direction, to the backwards direction. So whenever we cross this x-axis, that's when we turn around. That's when we switch directions. And that's true for any velocity graph. So that's what these x-intercepts mean. And here's this other factor. Since the velocity is the rate of change of our position, any change in position is given by a definite integral. So if we want to know our change in position, which is displacement, we would just find the integral from wherever we're looking for. So let's see. Yeah, that's the gist here. One last thing I guess I can say is, so right here where we turn around, our velocity is 0, because the 0 is, at time is 0, we're starting out going 5 units per second. And since our velocity is decreasing here, that means we're slowing down. So we start out fast, we slow down until we turn around, we start slow, and we go faster and faster and faster in the negative direction. So with that being said, let's take a look. This question is, we're looking for our displacement from t equals 0 to t equals 10. So basically, for the first 10 seconds of traveling, how far away are we from home, from our starting point? And you can do this a couple different ways. You might just say, okay, well, these two triangles are clearly symmetric. And by these two triangles, I mean this one, because the integral measures between the function and the x-axis. These two triangles here are symmetrical. Therefore, this will be a positive integral. This will be a negative one, which means our displacement will result in 0, which means we ran a loop. We're back home. Not a loop, I guess I should say, a straight line. Out and back. We ended up back at our starting point. Or, to be technical, we would write this as the integral from 0 to 10 of 5 minus t dt. And then you can calculate this manually. So let's see, this will be 5t minus 1/2 t squared. Evaluate from 0 to 10. So let's see, 10 times 5 for here is 50, minus 10 squared is 100, 1/2 of 100 is 50. And then fundamental theorem of calculus, as we would subtract everything when you plug in a 0 for t, but when we plug in 0 for t, we get 0, so it would be like subtracting 0. So I'm just not going to write that. But anyway, so we're left with 50 minus 50, which is 0. So your displacement is 0. What does this answer mean? That means we are back at our starting point. So we traveled out for 5 seconds and then back in for 5 seconds and are back where we started. That's what a displacement of 0 means. If you have a negative displacement, that means you are, let's see if we're, okay. So if we're going for a jog, we're starting at home, we go out, we go back in, and we travel backwards a little bit more. So a negative displacement means we traveled backwards from our house a little bit extra. So we ran extra. Okay, let's keep going. So cool. But displacement's cool, but what if we wanted to know how far we actually jogged? Integral doesn't help. So how could we do it? Using calculus. So integrating the velocity graph is only effective if you move forward to find the total distance, because then your velocity would always be positive. So we need to look at the speed graph, because speed is the absolute value of velocity. So it tells us how far we're traveling compared to time. So speed is the absolute value of velocity, and here I have this original graph, and I changed this bottom part to a dotted line, and I reflected it over the x-axis. So now this is our speed graph. So, which is, the total distance traveled will be the integral from 0 to 10 of the absolute value of the velocity graph. So for us, that's 5 minus t dt. But we don't know how to integrate absolute value functions, so what we're going to do is split this into two separate integrals. This equals 0 to 5 of 5 minus t dt, or you could just, use areas of triangles to calculate these as well. Anyways, so it equals 0 to 5 of 5 minus t plus the integral from 5 to 10 of this function, which is going to be, positive t minus 5. So this will be t minus 5 dt. So when you solve these two integrals and add them together, you will end up with total distance traveled 25 units. Oops. That's how far we actually jogged. Let's see. And that's it for this problem. So the important things to remember are the relationship between speed, velocity, and position, and knowing that the integral of your velocity graph gets you your displacement or your change in position, and the integral of the absolute value of the velocity graph will get you your total distance traveled.